Here we're going to look at Achievement Standard 92045 under NCEA. So this is a physics standard where we are investigating a phenomena, and this time we're going to do that through two investigations. So both of these investigations involve a spring-loaded trolley. In the first one, we're going to consider, or we're going to investigate how the force of a spring as it's being compressed inside the cart changes with the distance that the spring is compressed. And in the second investigation, we're going to look at how the compression distance of that spring relates to the maximum velocity of the trolley once it's released from stationary. And I've included the blurb from the standard there, which is highlighting the different criteria for achieved merit and excellence. So in the first investigation, these are the parts we're playing with: the force sensor, a data logger, and the cart with a spring, and the spring can compress inside the trolley. So once we've gathered and processed our data, it might look a little something like this. I'm not going to go through the individual steps of how you calculate your averages, etc. I think there's other videos that you can watch for those. So here I've got a description of the relationship using evidence, and it's important to point out here that the using evidence in the standard means that you can do it with your raw data, not your process data. But I would always recommend using your process data, because to get a grade beyond achieved, you need to be referring to process data, which means that you've either worked out an average, you have perhaps tabulated that data, or you've produced a graph of the data. So here's three different ways that we might be looking at how we would process our data. So the processing is not required for achieved, but I would always expect you to do that processing, and then just to get in the right habits, always use that process data whenever you're referring to anything in your write-up. So what we've said here for the description is that the further the spring is compressed, the greater the force that had to be applied. So we've described the relationship. And then the using evidence part. So I've pulled out at 0.01 meters, the average force was 5.8 newtons. At 0.07 meters compression distance, the average force was 38.1 newtons. We can also mathematically show the relationship in the x, if I was using x for the compression distance, is proportional to F. So as we increase x, we increase the force, or vice versa. And we need to describe a relevant physics concept. And so here, as a force is applied to compress the spring pushes back with a force of equal size. Now, we could take that quite a lot further, and we will in the explanation. That idea of equal forces, equal and opposite forces is Newton's third law. And we might also look at, since the system is stationary there, then the forces acting must be balanced for the object to be at a constant velocity of 0. So then moving into what a merit response would look like, we now have to explain how the relationship and the concept relate to the phenomenon, including reference to process data. So again, you've got to be using process data at this stage in your answer. So as the spring is compressed further, the spring pushes back with more force, meaning a larger force is needed to compress it by each additional distance. So higher force readings are seen for larger compression distances. The average force increased from 5.8 newtons at 0.01 meters to 38.1 newtons at 0.07 meters. So hopefully this gives you an idea of what a sort of bare minimum low merit response might look like for the first investigation. Now, because we've run this as two separate investigations, we're going to be looking to get a relationship and relevant concept for each investigation. And so I'm going to introduce us now to the next part of the investigation and run through the achieved and merit responses for that investigation, and then we'll put it all together into some complete statements at the end for each of the grade boundaries. So in this investigation, that spring, the trolley is being pushed against the wall to compress the spring by a certain distance. It's then released, and the maximum velocity will be read from the data logger. So this is an example of what our process data might look like. And again, when you're processing your data, that can look like calculating averages. It can be drawing a graph. It can be tabulating the data, although I'd expect you to be doing averages as part of that anyway. So for the achieved level response for this investigation, we're describing the relationship. So the compression distance is proportional to the velocity. And then again, we're referring to evidence values. I, again, have not used the raw data here. I've very deliberately used the process data because I think that's a good habit to get into. So then we describe a relevant physics concept as well. And what I'm saying here is that when a compressed spring is released, it pushes outwards in both directions. In this case, the wall can't move, but the trolley can. And so the force from the spring pushes it, giving it a velocity. Now that's pretty simplistic. I'd like to say a lot more about that, but I've deliberately tried to take I've tried to take it to a description rather than an explanation to show you the difference between an achieved and merit level response there. Okay, so moving on to the merit level response. So here we're explaining how the relationship and concept relate to the phenomena, and we've got to include that reference to process data. So a compressed spring pushes back against the force compressing it, according to Newton's third law. When the cart is released, the spring applies an unbalanced force to the cart, causing it to accelerate, giving the cart a velocity. The further the spring is compressed, the greater the unbalanced force, causing a greater acceleration, so the higher the maximum velocity of the cart after release. And then I've linked in relevant process data there as well. So here we can have a look at how that fits together as a whole response. So on this screen, you should be able to see an achieved level response that combines the information needed from both investigations. So that's our description of the relationship, the description of a relevant concept for each of the investigations. I won't read those out. I'll let you adjust the, pause the video and take as much time as you need to read through these. So then we're moving on to a merit level response for that question. And so here we're going a bit deeper. We are explaining the concept, the relevant concept in each investigation. And that probably involves a deeper explanation of the relationship as well, but that relationship is often explained through the relevant concept. And again, process data is a distinction for merit. So then the excellence criteria asks us to integrate processed evidence with the discussion of relevant physics concepts and relationships involved. So that's tying all together. So it's not just treated now as investigation 1 and investigation 2 separately. You're tying them both together to tell the story of the physics that's involved in this phenomenon. And what I've tried to do here as well is in physics, we can often explain things in different ways. And so I've tried to take an energy approach, which is maybe slightly less intuitive here, and give you an example of what an achieved, a merit, and an excellence response would look like using an energy approach. Hope that was useful. Feel free to fire any questions into the comments.